Hey everyone, Lazy Ben. Alright, let's have a quick look for at the notes for Wednesday. Check. I think we're working. Alright. So what do we do? Import Spidey and NPC, done. Combat with Spidey and NPC. So that's what we're on to now. So yesterday we worked on generating unique collision data for each animated rig. So the pathfinding would work with different sizes of rigs. So we make these bunch of these hashes, and each hash is just a 32-bit number which represents a collision cell. So if you were to hash a cell in the world, which is just a location XY, into a 32-bit number, do a binary search on here, it will tell you if it was in that cell and hence not valid for collision for pathfinding. Anyway, that works now. So if we run the game, we can see we've got these cells, which basically means this padding here will be different for different sizes of animated rig. These white cells, and it just makes sure that these white cells are the things that are used in pathfinding, and it makes sure that this doesn't go inside this zone here. Now, one of the problems we have, maybe I have to fix this, is that now on the level editor, if we were to put one of the guy's targets right next to it, assume, it won't be able to path there anymore. Which means that the pathing will break because that trigger, that pathing location, that patrol location, will be inside of these hashes here. So what we need to do is either emit a warning. I think we already do emit a warning. It says goal incollidable there. Or we path him as close as possible to that location there. Should mean he would come down to like here. Do we need to do that? That's the thing. We'll just make sure that all the goals are not near the collidables when we make the game. What would it require? It would be like, it would have to, if the goal was in the collidable, it would have to start testing all around until it found something that was not in the collidable, which would mean multiple A stars. But then this finding out that this goal is in a collidable is not necessarily expensive. So here basically, the NPC we're working on is Spidey. So this is returning goal in collidable. it's not expensive. We haven't actually done an A-star search yet. Okay, so what I might do is just rename this start cell and rename this goal cell, and then rename this goal cell hash. So we could even test this much earlier as well. So we've created the dynamic colliders there. And then we are just basically seeing if we need to redo the search there or not. So I think we could possibly do that there. So that will just, if we're less than 1 unit square away, that will just walk up to it. Okay, so that should even speed it up a little bit more. This is goal cell. Get this building. It's also goal cell. Right, so if we're in Collidable, we need to actually search the areas around it. So it's just saying the goal is in Collidable. It's not even trying to start the search now. And all, so we do need to generate dynamic colliders, which is a bit of time, but it's not, it's fine. So we could probably also do that. if we did do this down here, most of the time it's doing this actually. Yeah, so maybe actually, oops, maybe actually, because most of the life of the Pathfinder is in this set here. So maybe that is best there. So I'll take that back. We'll leave that where it was. So it's not taking any time at all to determine. So what we need, maybe, so the problem is we're advancing the patrol there. At goal, we're advancing the patrol. If the destination bounds area is greater than 1 and we intersect with it, we advance the patrol. I think that needs that there as well. So if the destination bound is greater than 1 and we just intersect in it. Hey, how's it going? Thanks for the raid. Below the Stone Dev. Just working a little bit on pathfinding at the moment. I'll show you. Get the game building. Andrew 900 460, how's it going? Got any questions, guys? Just ask. So right now I've got this little Spidean creature, and these white cells are just basically the collidable zones on his pathfinding, and I've put in a destination for his pathfinding which is inside the collidable zone. So I'm just working out maybe if I want to do some kind of soft pathfinding where we'll try and get close as possible. You can't get there because the goal is in the collidable zone, so he just doesn't do anything at the moment. I'm trying to work out maybe if it would be like nice to get as close as possible and then advance the patrol to the next trigger. Right, if I move it out and then relaunch it, it'll just be able to do it as normal, or whether it's just not worth my effort and just to continue, because goal in a collidable for that type of thing's kind of an error with where I've built the level. Fellow low level bro, alright, yeah, pretty low level. So yeah, he can go and he can do his pathfind, his patrol now. So this is eventually going to be an enemy. I'm working on combat and I've just imported this Spidean creature into the game, and he'll be an enemy eventually. That's the main goal this week, work on combat. Yeah, Andrew, if you've got any questions, just ask, no problem. Thanks for the raid. Oh, thanks, man. That's awesome. Much appreciated. Much appreciated. All right. So maybe I'll just leave it. Maybe I won't bother. Maybe I won't bother doing this soft. Well, the thing is, it's be quite quick to just find, I'd have to like scan outside. I don't know. Then the alternative thing we can do is work actually on the behavior for Spideon. So I can make these behavior trees, and the plan was to make a behavior tree for combat. I just built this last week, sorry. The plan is to make a behavior tree for combat, just so I can test out this behavior tree system properly. So I might do that. I might not worry about... My main concern is these regions don't really show up in the editor, these white regions, so I might place it here and then the pathfinding will end up failing. I don't know. I'll have to think about that. Anyway, yeah, I think we'll just work on these brains. So these NPC behavior is called a brain file. So I need to make one for the Spideon guy. So we'll do that. Oak Spirit, thanks for the follow. Yeah, if anybody's got any questions about the game or the engine or coding or anything. Been coding for a long time in my life. So yeah, I love talking about coding. Alright. So we'll do the behavior tree thing. So we're just going to make a combat.brain, combat test.brain. And then we'll have a root node, and we're just probably we won't do anything. We'll just have a root node for now. Okay. I'll get this one up as reference. And we need to make a behavior. So we'll just have a root node and we'll save that. And then we'll make a behavior. So it's in the behavior controller, right? So we'll make an NPC, we might make a behavior types file actually. Yeah, do it in here. So behavior types. There's going to be lots of these probably in the game and in the engine. So rather than have the behaviors in the behavior controller file, we're going to have a it in the behavior types file instead, because the brain controller is more like a system. It doesn't care about the behavior types. And the same for the test actions. And same for all the actions as well. Now we might possibly test action types file as well. Behavior action types file as well, maybe. Okay, so we'll include behavior types. Right. So let's just see if this builds or not. So what do we need? We need to forward declare these here actually. Okay. I think that needs to be in here. So that builds the behavior controller now. So that needs to be moved over, that needs to be moved over, needs to be moved over, that one, that one, that one, and that one, that one, that one. Okay. So all these need to be moved into the behavior types file. Okay. So that needs to include the behavior controller. DT2. So we need to include the game state, I think. Patrol state. We need to include game patrols. It's the BM engine game patrols, I believe. And then we need to include the BM engine game dialogue. And we need editor colors. We need the content cache as well. Like this morning. And the editor window. What do we need the editor window for? Oh, because we're opening stuff in the game editor. All right. So that means a behavior controller can get rid of all them. Probably don't need them. See if that builds just like that. does need game patrols apparently. Yeah. Alright, cool. So we have also these. That needs to go in behavior types. Check both of these files compile. Right then, so we've got them all moved over now. I'm going to write another behavior type, which is going to be called behavior combat. I'll call it behavior combat. I don't know if we're going to have different types of behavior combat though. We can always rename it. That'll be fine. Take out that. And we'll take out that. And put it in here. We could probably take out the test action as well. Oak Spirit, what's the template for? These. This means this is called what's it called? Template specialization. So it's a way to do inheritance kind of. So I have an object UI renderer, like base instance somewhere. Can find it. Maybe I don't have a base instance of this one, but it allows me to just basically select a type T and call draw on it, and this type T can be anything that implements the draw. So it's kind of like a virtual function, but it's not, there's no V table, it's just hard coded. So the behavior combat implements this draw. So it just allows me let me find one that actually implements. This behavior test implements that draw, and it just draws a text box. So the editor can call like object UI of type T draw, and it'll go to the right type and call draw on it. Do you know what I mean? It's just inheritance really, but without doing like a base class. And it means it's evaluated at compile time rather than at runtime. So it's just, it doesn't have the overhead of a vtable. Template type name T. So that's to create a specific type like here in the array. Type name T, well, lem. And that'll create an array of integers if you do array base int. Whereas this is more find this type and do draw on this type. It's a bit complicated to understand. I have to see if I have so the text serialization. So here we go. So we have a base version of reflect type, which does nothing. So if I do reflect type of something else, it's like overriding what it does. Find an actual version of it. Reflect type of animation. So it's just the same class, but I've got different functions. And you don't actually even have to have that there. If you don't have that there, it calls this one, which does nothing. Do you know what I mean? So it's like overriding, like inheritance. Whereas I don't think you do that with just doing template type name T. You do that on the base instance, but then you can kind of derive off that. Yeah, it's a little bit more like an interface, I suppose. Yeah, but it's hard. The difference between a normal interface, like I could have had this like virtual. If I can type, I can't type this morning. Equals 0, right? And then not have that there like that. But then every reflect type would have to inherit off that. So it'd have to do like struct foo and then inherit reflect type of something. But you don't need the inheritance here. And when you do this where you inherit it like this, that's a runtime check to call the base class or not, or to call the implementation. Whereas doing it the other way is compile time, which just basically means that it's you know, there's no overhead in calling these inherited like this straight to it. Yeah, it is good. You just try and set up a simple example for yourself and you'll see, yeah, there's no vtable. It's called template specialization, I think. I mean, cppreference.com is very hard to read, isn't it? So yeah, they define the base and then they inherit off it using this to say it's a specialization. And you supply the types of to the base that way. And then if you were to call a method, it would pick the right one at compile time. Yeah. It's good. Yeah, no problem. If you got any questions, I love talking coding. It's fine. So what were we going to take out? We were going to take out the test action, weren't we? We don't need a test action anymore. That was just, I just had that there when I was writing the system out. All right, let's just see if that builds. Okay, so we were going to make actually another behavior, weren't we? Behavior combat. We will implement this method if it will let me. There we go. Okay, so let's just build. That should allow me to set the behavior tree to be the combat behavior now. Yeah, and I have these lists of types here that extends this kind of system, so I can loop over the types and call the right draw if I need to, so the editor knows. So if I put these in this list, the editor knows about these and can start calling these from the editor, all this stuff from the editor if it wants to. So it just gets the list of these types. That's kind of a little bit how I do reflection with the game editor. So now I've added this into this list. When I do a when I load up the editor, I'll be able to select this from a combo box. Oh, really? Yeah, I mean, I'm largely self-taught C++, and I did work in the industry a long time ago for a bit, but then I went off and did my own thing. So I've had no real training at all, so it might be a bit, the way I do it might be, yeah, I don't know. Slop code. Oh, really? Yeah, I really like, one of the things I'm interested in actually is good API design. If you can, that's one of the things that I like. Good architecture. Trying to come up with cool ways to design systems. So the way I tend to design systems is so this behavior controller like handles all the stuff to do with behavior trees in the engine, but it doesn't care what type of behavior you hand to it. So you just write the system and it's done, and it's all quite generic. I mean, it's all very generic. There's no like, doesn't know about any behaviors at all. And then when you write these behavior types, you just add it to a list, and then the system behavior controller as the system can just call the types, and it just knows what types it has to work on, and do that all over the place. Combat begin. So we need to actually implement these. And it's really good for extendability of the system then, because you don't have to kind of touch the system to extend it. You just write these types and then add it to these lists. So there's like, these are the behavior types, and I'll write all the behavior types for the entire engine or the game. This is an actual game part of the code base here, so this will be part of the game. And then I have a similar one for actions. So these are like actions for the NPC, for the behaviors. I don't know if you know much about behavior trees, but that's what I'm working on. Yeah, I mean, slowly all this stuff's come into my coding over a few years, like templates is one of them things where it is also very easy to make things really complicated. And that's one of the downsides. But the way I try and get around the complexity is everything's laid out the same. So if I wanted a new behavior, I'd just implement these 4 structures it is for the behavior, put it in that list, and then that's the new behavior. So just try and take some of the complexity away, so you can just copy the actual, you can just copy it and change it rather than have to remember how to write it. Yeah, cool, thank you. So I've got this behavior combat now, I've just put in. And because of the way that I've written the editor, the reflection's all just done using these structures. So I haven't told the editor about this behavior combat specifically, but it knows about it now. So if I open up the combat brain, I can just sign behavior combat there now. It just knows about it. So yeah, it does a bunch of reflection work and stuff. So the reflection's just done using one of these structures. So it's just done with this. So anything I want to expose to reflection, for instance, the name. If I put a type in, if I put in something like, this was a test one, so it had x equals 2. I'd just say that x was the obs at x. Like that. And then if I was to then click the test one, oh, it has to actually be in, can't be in there actually. So if it has to be in a patrol. So if I was to assign the test behavior to the Spidean, it has X there as 2 reflected into the editor using this structure. But this is used for in a lot of things. It's not just used for the reflection into the editor. It's also used to do things like serialize it to disk as in text format. So if we look at one of the patrols, so she has a behavior test and its x is 2 is there as well. So this was a test one that I made. So it uses also that reflection to do the things like yeah, serializing the text file and also printing it onto the screen in the game, you know, in the console or just as a label in the game itself. Yeah, it's good. And if something's trivially binarily serializable, as in like there's no pointers in here, you just have to write that, and then that'll just serialize the whole structure as a block of data. If you're wanting to actually serialize, you know, like do a deep copy, you would implement a different one. So So look at game. I don't know if it's... Yeah, you implement binary serialize. That's a complicated one. That is actually much simpler. Yeah, the game levels. So here, because we have like an array of points, so it's not just a block of data that needs serializing, it's actually like that's data and that's data and that's data and that's a pointer to data. So you have to implement this one instead of the trivial one, which is just like, how do you write it? How do you read it? But that's simple enough. Like the serialization system knows that this is an array. So you just do it this way instead. And then that'll do a deep copy of points into the writer, which whatever writer you're using. So it could be like a buffer or a file or something like that. Spirit of Steel will lead you. Thanks for the follow. If you've got questions, just ask, no problem. Just working on behaviors. Building out a system really for the editor. So I want to give, so I've got Spidey who goes on patrol. So this is a patrol graph. So he just goes to locations in the world. From location to location to location. But you can actually assign behaviors. So I want to assign a combat behavior. And the combat behavior is one of these files. This is a brain file. So this is a behavior tree. So I can do like a selector. And then we can do like a couple of actions. So it'll select something to do. And these actions actually are meant to be logic in the game. So I've just written this system last week. So combat is just going to be testing this system out. But all I'm going to do is I'm not going to have a selector. I'm just going to write an action. And we're just going to... My first thing I thought I might do with Spidey is get him to flee. Get him to go into cover somehow. So I've got this combat room. And I've got these crates in the middle of the room. And what I was going to do is just have him... If you were to move around here, he would move around here behind the cover. And he'd try and stay out of your way. Because that could be eventually in the that could be a fallback eventually. You know, if he gets low on HP, he might go to cover or something like that. So that was the first thing I was going to try and implement as one of these actions. So I might just remove that behavior now, because if I put in that behavior, it'll stop Spidey and walking around, I think. So yeah, we'll just remove that. And we'll just write whatever this action is going to be. So the way the behavior trees will work is it'll come into the root and it'll evaluate the conditions on the root, of which there aren't any. But we can add conditions. If the conditions succeed, all conditions are met, it will fire this action. And this action is just like do something. So the first thing I think I might try and do is like, let's get him into cover. So that means we need a new action, right? So we're gonna have something like combat find cover, like that. And we probably need to know what NPC want. No, we'll get it to work on the current NPC that owns the behavior. That's what we'll do. I mean, we could say Yeah, we might actually say whatever NPC this is. So we'll say Spidey and find cover. So we'll say, yeah, so we'll say find cover. So this is going to be NPC. And we'll add that into there. And then we just need to implement these and this. We'll just draw the combo box. And we'll just say fail for now. So these actions fail. Fail and enter, fail and tick. Check that builds. So what I really need actually in the behavior controller is it not to have to include behavior types. I don't think it does. It does here. Is this used anywhere? No. So we can take that away. Obviously, I don't want to include behavior types in the behavior controller header because I don't want to have to keep triggering builds, big builds. So what I also need in the editor is I need some visual kind of feedback to what node is being executed as well, which we don't have. So I can track, because these trees could get quite complicated. Okay, so this needs to include the behavior types. So we might work on that as well, actually. We might work on some feedback in the editor. I want the editor to highlight if a behavior node is being fired or not. Alright, while this is building, I'm just going to take a couple of minutes to make a cup of coffee. Alright, I'm fresh massive mug of coffee. Built with no errors, which is good. So we've got a single action node in the behavior, and we're just going to assign that the cover action. And all that's going to do is tick until the NPC can find cover or not. Now, there's no concept of cover at all in the game. So we will have to figure out how do you do cover. Find cover for Spidey. Okay, so we need to, what we might do is attach it to an activity. So I made it so you could attach NPC behaviors to activities. So activities are like, go to this location and do this activity and then move on. And we're just going to assign it a behavior combat. Yeah, one of the things I actually needed to do was have it up in the brain. Okay, we'll put that in next. We'll save this. So he's going to go to this trigger and he's going to tick the behavior combat tree, which is this tree. So we should end up, hopefully, we'll put a breakpoint on here. And we should end up there. It might not. This is all testing this system out because this is a brand new system that I wrote last week. So the point is to find problems with it. So we'll see if we find any problems. So he needs to walk to his first. Okay, so he didn't get triggered. So there's your first problem. It does summit. It definitely like flickers or something. Something's happening there. Okay, so let's figure out what went wrong. Maybe you cannot have an action directly off the root. Maybe that's what the problem is. So if I put a selector node in, like that, let me run this again. So when he gets down to here, it should get a breakpoint. No, he didn't. Okay, well, let's debug that. I want to debug the case first. Well, I'll debug the case with the selector first. Where are we? So it's where we get an at go, I think. Okay, so this is going to advance the patrol. So it is an activity node. Begins the activity. So the activity ID, set behavior instance. Oh, it's because he doesn't have a behavior controller. Right, that's something we want to do then. With every NPC, do we want to give him a behavior controller? I'm not sure. So we need to do entity state types, spawn, on spawn Spidean. So we need to do game state, create behavior controller. Alright then. So now let's just see what happens. So we get that breakpoint. Still didn't work though. But he does have a behavior controller. Yeah, we might want to give all NPCs behavior controllers by default. He does have a behavior controller. Doesn't have any brains though. Okay. So, oh, maybe we. Let's just check we've got all the things set up properly. So patrol, Spidean. Oops. Behavior combat. Yeah, so we also need a button here so we can open the behavior up. Ah, it's because that is set to behavior test. Okay. So that might not be a bug. So it wasn't really a bug, it was we didn't give him a behavior controller. Ooh. And we had a problem there. So it found the brains and everything. That is very strange, that error there. So this is for Spidean. So might possibly. So this is becoming corrupted somehow. Let's do it. Let's rebuild this. Some coffee. There's nothing there really. It's quite a big copy. Nothing there which should lead to corruption. So hopefully memory corruption. Hopefully it's a build problem. If it's not, we'll have to really investigate that. You know, like I've had this whole thing working before with a different NPC and it was fine. We shall see. And what we will also do is rebuild the brain groups. All right. Could be because behavior combat doesn't have any fields. That problem is happening. Oh, it didn't crash anyway. No, it was fine. It was just a build problem. Yeah, no, it's fine. Just a build problem. Alright, so we need to figure out why we are not getting hit here. So behavior controller. So we do assign it a brain. So where was it again? Game state. Tick patrol. Tick NPC patrol. So it's here, wasn't it? Advanced patrol. Follow this through and check why it doesn't actually start the tree. Begin NPC activity. Begin. So it finds a behavior controller for this. There's one brain in it. So it says activity ID. It's got a proper activity ID. Requested behavior instance ID. So it just sets it. And then in the behavior controller, tick. We've got a brain. So it doesn't have on begin for the behavior type. Does it actually though? Ah, maybe it's because we need to say it's running. Yeah, so we're early and out of the behavior, so that's not a bug either. Okay. So running. So this is a way to let's say the behavior it can't even start running. All right, there we go. So now we're going to tick this find cover. Yeah. It's not me remembering how my own system works. So behavior on begin has to return on running. It has to say it's going to run. This is the way in the code to actually fail the entire behavior if you want to. So if I just return running in both of these, this should just basically, the Spidey should walk to the trigger and then it should just not do anything because the behavior tree has taken over execution of the Spideyans, of the Spidey in general. So it should just go and sit down. There we go. So the behavior tree is running now. So what I want is some visual feedback on the actual behavior here to say that, because this node is running now. So I want some feedback to say that Spidean is running this node. What I might actually do is test it can work without a selector. So if we just do this. Yeah, can work without a selector, because I don't really want a selector because there is only one thing. All right. So also I wanted a box. I wanted an open brain box to show up, didn't I? We'll do that as well. So if we just open the Spidean's patrol, click this activity. I want like an open brain box. So is there anywhere else I want to do open brain? There. So wherever we do on brain behavior, it isn't anywhere else. So let's just look for behavior. So we want it here. So this is activity behavior name. So maybe not there. We'll do canvas, draw separator, and then we'll do it here. That does the open brain already. And here. Oops. And this is just behavior name. Okay, so that should give us a couple of buttons where we can open the brains up. After these compile errors, I've gotten sorted out. Content cache. To include the content cache, and the editor window. So we need to get feedback from the game about what is running, what action node is running. So if we open the patrol up now, you should be able to click that, and then it should have an open brain, and that will open the brain back up. Oh, we don't need it there though, because the brain is already open. So how are we going to do that? How are we going to get feedback? Okay, so hopefully this button disappears. There we go. Just want it there. Yeah. So how are we going to get feedback then that this is running in the game? So it's currently running, right? So this is being ticked. So it's in here, it needs to happen. So this is a brain instance. We need to get out of this lambda. Here we go. So we've actually got the node ID, which is great. Do we have if the brain instance is running or not? Yes, it is running. So we need to get all the running brain instances, I think. So we're going to do TArray brain instance get running brain instances. So TArray brain instance. Well, no. We don't want to copy though. So brain instance has an ID. So, oops, not there. Get running brain instance IDs. We don't want to return, we want to copy the brain instance. So TArray U64 result. Say brains.get count. Then we want to return the result. Well, do we even want it? We won't do that. We'll go for auto brains. If brain state, what was it? Brain behavior state. It's behavior state running. Result to add brain get ID. So that'll return all the running brain instance IDs. And then we want get brain instance, get behavior instance state. That just returns a state. That should be get brain instance behavior state. Call them all behavior instances. Well, maybe they should be called behavior instance. Oh well. I'll call this get running brain instance IDs. Behavior instance IDs. Maybe it should be called behavior instance. Instances may be better. Spelled it wrong there. Okay. No. Instance. Oh, spell anything instance. No. Brain. All right, cool. So I might actually change this to not, because now it's a behavior instance. We could put just the brain in there. And then when we do this, we just say that the brain is the brain. Yeah, so the instance has an instance ID. That can be changed to ID now. Yes, it's better. So it's instance brain.getID. So the instance ID just should be called ID, but I couldn't because the brain had a brain ID before. So this is the instance ID, not the brain ID. Well, yeah, this is the instance ID now. So this is brain.set, no. Set behavior is undefined. So is that on the brain? Yeah, so this is brain.setBehavior. And this is actually a public now. Make sure it happens on this brain though. So all these fine nodes is brain.fine node. That one. Get behavior. This is brain.getBehavior. Find node by index. This is brain. Find node by index now. All right. Build that. Before we build that, this now can be called ID. So now we can get running behavior instance IDs. See, I wonder if we could just say get instance IDs and return standard span of instances. Get instances. Get behavior instances. Instead. A behavior instance though is a game level thing. We can definitely have that. But we probably do need this. Get behavior instance. Yeah, we'll say get running behavior instance IDs actually. So now the editor can get these IDs and it can ask for the running action. I'll say is running action or something for a particular instance ID. Current node is action. Something like that. It's just ID. can have something like bool. I could say behavior state, get behavior state of instance. Behavior state of instance. Use your instance ID. And then we want like is an action node really. So we want something like bool current behavior. Action node. Current behavior node. Current instance behavior node is action. I think we just need those. Return instance state behavior state. This is if auto instance instances dot find instance ID if instance if auto node equals instance dot brain find node instance current node ID return node is behavior action. That's to say current instance behavior node is action. Okay. So that means for a given behavior controller, we can determine those things. So the actual API into the game needs to specify what entity we are working on. Maybe it just needs to get all the running instances. So anything to do with behavior in here. Yeah. So we want It's build. Looks like it's going to build fine. So we need to get running behavior instance IDs. So maybe actually you just need the node, don't we? So this could be get running behavior node IDs. Node ID. Get instance behavior. Current instance behavior node is action. So we don't actually need that now if you use the node ID. So we don't need that. So this is actually the node ID. For auto instance and instances, if auto, if instance, if auto node equals instance of brain, find node, node ID, return node. It's actually on the instance, not the node. So if it contains that node, so that node actually no, hang on. Let's go back. Behavior instance IDs. Get behavior of instance. Get behavior state of instance. So I think we do need that. We want to say also get node ID, get current node ID of behavior instance. That's what we need. Return instance current node ID. Okay, so now we have get current node ID of behavior instance. Get running behavior instance IDs. Okay, so the game needs, we'll do it here, tier 8 U64 get running behavior instance IDs. So that's tier 8 U64 result. So we want to do for auto behavior controller and get game state behavior controllers result copy from it's a problem. Seems fine. So we do result from copy from BC get running behavior instance IDs. So we just build up a big list of all the IDs of all the running behavior instances, and the editor can use those now to see if a particular node is running. So we want to get the behavior state of a particular node. So we want to get current node ID of behavior instance. This is for instance ID. Right, now a 2-minute break. I just need to nip to the loo. Won't be long. All right, I'm back. So we're just going to return 0 by default at the end. But what we're going to do is we're going to go through the behavior controllers. I'm going to go BC equals BC dot get current node instance. Node ID. Return node ID. And then we just need to know the actual state of the node. Which I assume current instance behavior node action. Current instance behavior node is action. Get behavior state of instance. So we want eBehavior state, get behavior state of instance ID. So this actually needs to be optional. That needs to be optional. Actually, this needs to be optional as well. So it might not be an instance ID. Doesn't know about behavior state. So that means that needs to be optional as well. State of instance state. If it is, we'll return it. Okay, cool. So now we need to go into the actual editor code and start drawing some state, whether it's running or not, whether the node is running. So that would be in the brain editor. So we've got tick board panel of the node. So I can maybe do it here. So auto game is get game. So we kind of like want. So how is this going to work? Instances equals game get running behavior instance IDs. Auto instance node equals game get node current node ID of behavior instance. So if we have an instance node, and we can say if instance node is equal to get ID behavior state of instance, right? Okay. What that means now is we know the behavior of this node, and we know the instance ID. So all we're going to do is going to say if behavior equal to behavior state running, and go auto bounds equals get bounds. Node bounds. How do you get the bounds of the node? Get world bounds. Nuke Bird, hey, how's it going? ID is the ID of this node. That we're in. Hope you're alright. So it's what it's doing is, so this is feedback in the behavior tree for what node is running. And it needs to go to the game to get what behaviors are running in the game. So it gets the IDs of the instances of the behaviors. And if the current node is this one, get the behavior state of the instance, because there's only one, even though it's multiple nodes, there's only one behavior state of any tree. And if it's running, we can just draw something, draw a green box around it for now, I think. That's the plan. But we're going to inflate it a bit. Yeah. The brain editor. And I do things like destroy brains. So yeah, we'll have a bounds here, and then we'll just do canvas, draw quad outline in world, bounds, pixels to world, say it's 2 pixels. We'll just say float color, well, yeah, editor colors, green. Editor, let's see, order. Can we do that? Let's put it in max for now. So it doesn't know about behavior state. Where is that? It's in the behavior controller. Not the best place for it. It should probably be in game brains. You're right at the top. Alright, see if this brain editor builds. A custom STL alternative. I use a bit of STL, and then I've written a lot of the containers I've written. I use what do I use? So this, so standard optional. The custom smart pointers. They're just optionals. Well, that's a U64. So it works like a smart, like it looks like a smart pointer, because you access it with the arrow, but it's standard optional. And then I have OptRef, which is standard optional for pointers, because the STL doesn't have, you can't put pointers into standard, or references rather, into standard optional. You have to use a reference wrapper, because it's a little bit unsafe. Now that's what they think. They think it's a little too unsafe, because all of a sudden you could start trying to save references to state and stuff. I do have they're not really smart pointers. I have pointer wrappers. And it's just like weak pointer. So I can just say that, like, if you get a weak pointer back, so if I want to return a raw pointer from an API, I can explicitly say it's weak, meaning you don't have to worry about it. Like, the API will clean it up. Or I can say it's strong, saying you have to free it. That's the only real smart pointery stuff that I've got. It's not really smart point. There's no reference counter or anything. We love doing it unsafe. Yeah. It's unsafe if you don't know how to use it, I suppose. But, you know, if you're going to use it, you should know how to use it, so. So, yeah. And I use standard span a lot. as well. Or in quite a few places. And it's only because I haven't written them. You know, I would write them if I was developing. I mean, you don't need to, but if you know, I have to wind back a few years, I'd have probably written standard span as well, just to understand how it works than an actual need. But now I'm on other stuff. I just use standard span instead. Standard span's nice because it doesn't let you alter the size of the underlying array from outside. I'm trying to find a place where I do it. Here. So I could return a reference to an array here if I wanted to. But the problem is then is that someone could just empty that array. And sometimes that you need to do that. Like a lot of occasions, the load save system needs to take these controllers and repopulate them, so you do have to return references, but sometimes you don't. Like eventually, if anything in the behavior instance needs to get saved by the game, like as a game save, and it needs, these behavior instances will then need to get repopulated, so it might change. Yeah, spans are good. I think they're okay, and it allows you to make this this could be const. Should be const really. Whereas if this was a reference to an array, it couldn't be const. If you're returning a reference to something, you can't really. Something inside the class, it can't be const. And also, another good thing about this is behavior instance could be forward. It's defined there, but if it came from another file, I could forward declare behavior instance if I used a span. If this returned the array or a standard vector reference, I'd have to actually include the file because it needs to know the size. This doesn't need to know the size of behavior instance because it's just 2 pointers. Whereas an array, a reference to an array needs to know the size. So it's kind of it's like handy, I think. But that's kind of it. That's all I really use from SDL. Just those 3 things. So all 2 things. Standard optional, standard span. I don't know what else. Nothing else, I don't think. Sometimes I use standard array. No, I don't use standard array either. They're from Magic Enum, which is another library that I use, which is not written by me. I have something called a fixed array. int 7. One, two, three, you know. I have that, which is the same as standard array. Forward declare for optimization. Forward declare for trying to keep down the compile time. Yeah. If you don't have to include a header file, you don't have to include all that code in the compilation. So yeah, you should try and forward declare as much as you can. I try and forward declare as much as I can. Just try and keep compile time down. Yeah. So I would forward declare these. So rather than include game brains in here, I'll just forward declare the brain instance there. Because they're only passed as pointers, well, references, so you don't actually need to know the type. Yeah, it is simpler, I suppose, to include the header file. When you get large projects, though, it really slows the compile time down. Because obviously, like, the include file might include loads of other includes, and then they will include loads of other includes. Yeah, exactly. Like, the compile time now is getting a bit long for me. For this, I think it can do a full compile in like a couple of minutes of everything, but it is a bit long. Like, I was gonna experiment with doing like mono builds. Have you heard of mono builds? So they are where you exclude all these from the project, and then you have one CPP file and you include them all in the CPP file. So it builds all these CPP files as one translation unit. And that might be faster. So I might take a day to have an experiment with that. So the Unreal build tool does stuff like that. It does rather than compile each CPP file separately, it will it'll batch. There's some C# stuff that actually creates these CPP files that includes other CPP files to try and speed up the build. Yeah, I use multi-threaded build, but I've only got 8 cores. It's an old computer. Yeah. Yeah, you can do full link time optimization and stuff, where you will look across translation units for optimizations for the entire program. Yeah, and then I have pre-compiled headers as well to try and speed up the build. But it is nearly a size now where the build's becoming slow. Yeah, it is. It definitely confuses people and scares people away. I've had people who've done C in the past, or C++ in the past, come to me, and they don't want to pick it up again because, like, they have to start learning about linkers and stuff. And then, you know, if you're a new programmer and you get a linker error, it's basically undecipherable what the error is, and it scares people off. I mean, C++ errors are pretty terrible anyway. Linker errors are even worse. Okay, let's build anyway. Alright, cool, yeah. Yeah, that's what I've done with this libbm. This is a library here, and then I have a separate solution which links it to another executable for tests, to run tests. Yeah, But I do it in a different solution, so I'd have to load it up in a different Visual Studio project solution. I did that when I was developing that, so it's a few years ago. Get a blank error. Yeah, that's interesting. Yeah. Yeah. I think it's good to have your old code, because you can look back. I don't have much old code. You can look back and see how much you've improved. Yeah, so the compiler might not even, if you're never using the function, it might not even get there. And that's why you sometimes get linker errors. If you start using it, you might get a linker error, even though it works before. Because the compilers, they just follow the code flow. And if the code flow never gets to the function, it just doesn't get compiled. Yeah, like if I got a new computer and it had 32 cores in it, it would probably compile in 20 seconds. It should be awesome. I might maybe get a new computer this winter. Maybe. Just the repo. I'll look at the YouTube thing in a sec. Oh, nice. 6 years ago. Cool. So your vertex array. So this is all your different. Yeah, so you've gone for like hierarchical different types of vertex array. Wow. So it does some like render some cubes, different materials. Awesome. So 6 years ago. What do I have anything that's really old? Let's have a look. All right, cool. Hey, IGS Ghost, how's it going? If you got any questions, just ask. Oh yeah, banging. Look at that. So you've got multiple materials, and you've got some. Is that doing like a cube map reflection there? Nice. ILB. What's IBL? IEM. PMREM. I don't know what those are. Oh, image-based lighting. Ah, I see it. Physically. Yeah. This is 4 years ago. Me. So I'm using the underscores there. This is really the only project I used the underscores on. I was just trying it out. Then I went back to using camel case. This is a project that I used to learn DirectX 12 with. I don't have anything that old though. Unfortunately. How do I even use this? It's a PHP there. Some C# stuff. Six years ago, you didn't know what int was. Yeah, I mean, we're all at different levels of coding. Have you used STL2? Yeah, I have used STL2. Yeah, I've used STL. Not for years and years though. Used STL a long time ago. I've always been more interested in like the engine technology, the games technology side. So whenever I've sat down to make something, rather than the games, you know, like I love games. But my learning's always been like, oh, let's have a look at what STL does and try and rewrite that to learn. Rather than just get STL and then use that to make game stuff. You started programming in 2009 when you were 14. In 2009, I was 24. 2009 is when I started professionally programming. I think. Well, that's when I was programming before that, but I was a student as well, so for money, doing other things. Just give me a damn window, yeah. So like my line of thinking would be, how do I make something like this? Oh, not that. So where you can like swap monitors but not using STL. Like, how would I do that? Or go to a full screen borderless window, and how do you revert it? How do you get all the resolutions and start rendering at a weird resolution? So look into the Windows window code to see how you would do stuff like that. How do you go full screen at 144 FPS and stuff? Yeah. Yeah, so if you wanted to go cross-platform, you'll save a lot of time. Yeah, using STL for sure. The thing is, the Windows part is of this engine anyway is very small. It's only one file. So if I did ever want to start drawing on Mac or Linux, you just have to rewrite that one file. So it isn't actually that much. And it doesn't just do the Windows stuff, that file. It does stuff like open file dialogues and save file dialogues and all that. IGS Ghost, thanks for the follow. If you've got any questions, just ask, no problem. Oh, love talking about coding. Drawing sprites yourself. Yeah, sprites are complicated, man, in this engine. So I'll show you. So this is Pix. So this is what you can look at GPU stuff with this. So if you just go down here and take a capture. You can see how the level is drawn, right? So that's the ground. And you see all these little sprites. This is to clip out white space, because what the number one cause of like FPS drop is just drawing nothing at all over itself, or drawing over itself. So overdraw, right? So if you draw something, then you have to draw something over the top. That's really bad for a graphics card because it can't multi-thread that. It has to like draw the first thing and lock the other, it can't draw two things at the same time if it's the same pixel. And then it draws those crates, and you see how it's split up to get rid of the white space. So there's all sorts of things that go in the engine to create these meshes. It's all automatic. Are you making sprites myself? I draw stuff in Photoshop, yeah. Like I've drawn all this. Is that what you mean? Why not a single quad, 2 tries? So yeah, 2 tries, 6 vertices. So if you think about a unit of work, the GPU has to do 6 units of work there. Whereas if you can cut out these pixels, that's hundreds of pixels. So you've cut out hundreds of units of work. So you've got more vertices. But if you think about the vertex shader and the pixel shader is just 1 unit of work. You're cutting out loads of work. so you can have more vertices for less pixels. You should always try and choose more vertices for less pixels, fewer pixels. And if something was to come and draw here, there'd be no overdraw, so you're saving that as well. And then these meshes actually don't come from me, they come from Spine, so they're like a little bit mental out of them. So there's a bunch of overdraw there. But that's just the nature of rigged animation, unfortunately. And then it starts drawing all the debug stuff. So you see how that's been drawn as a fan there. So all this kind of like how these things get drawn, that's all kind of, the engine handles all that. So you just import something from Photoshop and it makes a mesh for it and stuff. So pixel shaders usually are where all the work is done. Most of the work. And there's far more pixels than vertices. There's millions of them in there, really. There's your screen buffer size, and then there's also all of your render targets, all of your overdraw. There's millions and millions and millions of pixels, so if you can cut them off, if you can just not draw them, that's always a win. Nav mesh. There is a nav mesh. I use it for pathfinding though. It don't get. It's not really part of the. I think you can draw it as a debug. Oh yeah, this starts drawing the hood. So there aren't many draw calls. It's a pretty heavily batched render of this. I mean, there's actually not much happening on screen, but like a lot would get batched in these batches, a lot of the drawing anyway. Maybe go to a denser level. A denser room. Let's make this game a bit bigger. Whoops. This one's probably the... Oh, I haven't got pics open. Whoops. Need to be doing this in pics. Okay, so this is a bit more of a mental room, this. Okay, so this is doing more stuff because it's drawing out reflections and stuff. Yeah, so the better algorithms you can find for generating these meshes, the better it will perform. So if you can come up with a really good way to cut out white space and minimize vertices at the same time, that would be awesome. That'd be totally awesome. You know, you always want to try and cut out all the white space you possibly can, because it just means you can put more stuff in the level, you know, and not affect performance. You could have really heavy, really good grass density and stuff. Ooh, what's this? Yeah. So 3D is kind of a little bit of a different story, because you're actually rendering, you're actually texturing geometry. So obviously you do want to make your geometry as simple as possible. The thing about 2D, which is more difficult to handle, is everything's got alpha. If you texture geometry, if you're just texturing geometry, there is no white space apart from your transparent objects, and you can just draw from the front of the camera all the way back with a Z buffer, and you cut out loads of overdraw doing that. So you get rid of overdraw doing that. You do a different kind of technique. Whereas if you're doing 2D sprites and everything's got alpha, you have to use a different technique. You can't draw from front to back if you've got alpha and everything. Yeah. So you can't draw from, if you've got something transparent, you've got to wait to the end. You've got to reorder your things to make sure that you're drawing the transparent things at the end. If you think about doing something with sprites with alpha, it's like everything. It's got transparency. Every single sprite has got transparency. Or you can assume it does. Not everything will, but you have to assume it does when you render. So you have to render from, you can't render from front to back, for example, because it just won't work. You have to render from back to front. So all of a sudden you've got this overdraw problem where you're drawing over the top of things, which is really slows down GPUs. So one way to combat that is to really heavily cull all this white space out. Oh, really? Cool. Nice. So yeah, there's a few more draw calls for this level. So it has to build reflections. Oh no, it doesn't. Oh, it's just drawing them. I wonder what that. That's a bug now. That's an error. That shouldn't be there. It's not drawing any reflection batches. Sudden Apollo, thanks for the follow. If you've got any questions, just ask, no problem. Yeah. And you can use things like percentage closer filtering and stuff. And that helps. Although it doesn't looks good on some things and not on others. So yeah, it's drawing from the top of the screen to the bottom of the screen to make sure all of the draw order is like all the alpha blending is correct. Yeah, Y ordering, yeah. So it draws the ground. That label shouldn't be there, ignore that. It's putting that label in and then doing nothing. It is separating the actual batch though, which is interesting. Should maybe fix that. It's a bit of a bug. Okay. Let's just see. So what we're actually doing right now is trying to get feet. So this Spideion's walk into this trigger and he's stopping because he's running a behavior tree. So we need to open his behavior tree. So if you go to his patrol and open the brain there. Oh yeah. So it's running this action. So we're getting this green box now to say that the Spideion's running this action. Now this action can be, this is instanced, these brains, so it could be multiple things. So we probably need to say who is running this action as well. So how do you do that? So the instance has an entity ID. I believe, and that the entity ID is who is running it. So we need to do U64 get entity ID of behavior instance. So if auto instance equals instances, I'll find instance ID, return instance entity ID, else return 0. Okay, can't return 0 at the moment, so that's the hero. So there's a problem that I have where this is wrong. The hero shouldn't be 0, the hero should be 1. I will change this. If I change it now, it'll just screw up all this test. All the world right now is just test. When I sit down and start properly making the game world, I'll change this. Hero should be 1. And there should be an unknown NPC. That was a bad choice doing that, because that's caused problems all the way through. So we'll just return 0. We'll return 0, even though that's the hero's entity ID right now. Did I draw the graphics for the game? Yeah. The only thing I've not drawn is the hero character. That came with Spine, that. But I drew the Spidey and I drew the little enemy. And everything else I've drawn, yeah. We will get around to drawing the game eventually. Maybe not for a year or so. I don't think I'm going to do any art for the game. I need to get all of the gameplay systems built, which we're nearly there. Get combat done. And then I need to get the progression system. So I need to get, you know, a progression tree so you can unlock things, technology. And once that's done, we need to block out the entire game. And then once that's done, I can draw it all. Still right at the beginning. This is week 12, this. Of maybe a 3-year project. 3 or 4 year project, probably going to be. But there's loads of gameplay in now. Well, we've just begun combat, so combats will be in soon. And we've got plant. You can plant things grow. You can pick things. Got crafting. Got shops. Got chests. Got NPC patrols and chatting to NPCs. Got quests. Got loads and loads of stuff. Alright. Yeah, so we need to get who is drawing this. Not who's drawing it. We need to get who is running this node. So we want to go. So there could be multiple people running this node. See, there could be multiple instances running. So I think what I'm going to do is I'm going to go bool is running. Then we're just going to say is running is true. I could even do something like behavior state equals behavior state. Well, no. Yeah, we'll do standard optional behavior state. And we'll just set it to be the behavior state. Like that. I don't even need to do. Well, are we going to see who's failing as well? We'll just leave that in for now. And then if behavior state is running, we'll draw it once. Yeah, I've got another project that I drew a lot more on. I've shown this a couple of times on stream. So I did draw absolutely everything on this one, apart from the Marty McFly and Doc one. So this is where I'm pulling art from. This is the project. I finished this about 2020. So I drew these houses. It's a bit dark. Like a chili bush. So this is also a planting game. So you could like plant things and not much gameplay in this though. For this project, this new one that I'm doing now, I'm doing the gameplay first. This one, I drew it first, if you know what I mean. Yeah, so I'm going to have all sorts of like different plants and stuff for this game as well. For the new game, not this one. And they've all got things you can pick off them and stuff. Yeah. So yeah, there's not much. There isn't really that much gameplay. I've really concentrated on gameplay on the new one. Whereas this one I was like teaching myself to draw game art and stuff. But yeah, if you cut down all the pixel, cut out all the pixel overdraw, you can have really dense grass and stuff like this. It's all really super dense. Anyway, tune back in 2 years and the game will look similar. I mean, it won't look similar. The new one's a sci-fi game, so it will look all sci-fi, but it will be a lot more filled out with drawing. Right now this one looks not nowhere near the same or as good. Yeah, so this Midian guy was in the old game because he had combat in the old game, and he would go and like hide in the grass, and you'd be able to see his like tail sticking out of the grass and stuff. And then if you walked up to him, his big spike goes up. I'll show you. I'll open up the actual animating tool. So he has like idle alert, and he's it's looping. Oh, it's 2 idle alert. Where's idle alert? Idle alert. There we go. So that like pops up out of the grass when you like walk up into the grass, and then he can like attack you and stuff. Alright. Timber, how's it going? Yeah, I'm going alright, man. Working on combat now, so built a behaviour tree system last week, and I've imported this guy into the game, this Spidean character, and you're going to be able to, hopefully in a few days, you'll be able to react to it. I mean, I don't know if I will spend much on the attacking bit, but it's more to work on different states that this guy can be in to attack you. So I'm gonna put, the plan was today was to put in a flea to go and hide behind this cover, and we might get onto that. I've just found a few more other jobs. Like one of the things I'm doing is if you load up the brain, this is this combat brain. I'm just putting some feedback in so this Spidean's not moving because he's running this behavior tree, and this behavior tree just runs forever. So I'm just trying to get feedback of like, I'm put this green square in just to say that he's running this node, and now I'm going to write all of the instances of NPCs that are running this behavior. That's the plan. Just so I have some visual feedback, because these things are going to get quite complicated, I think, quite large trees. So I think it would be handy. Anyway, we also need to get the NPC names of every entity names, every running. So it would be game.get. We need to get the entity ID. So in the behavior controller, Get entity ID of behavior instance. Did we actually write that? We did. So the game needs that as well. It should be standard optional just to... No. It's fine. No, it should be actually, because the instance ID might be... No, actually, that's fine. So we need to get the instance. So it's kind of similar to this one. Get entity ID of behavior instance. Entity ID. Okay, and then in the brain editor now, if auto entity ID equals game.get entity ID behavior instance game.get entity name, and that's optional. Entity names dot add unique name. Now this is getting a little bit iffy, so I might just do this. If not instance node, continue. We'll leave that one. So we add all the entity names in, and then we kind of just want to draw them all out. We could do it use a string buffer actually, or a string builder. Entity names, push, add. So this isn't an array actually. No, just a string builder. Push. Add line name. Name. So I'll build up a big string actually of these names, and then we'll just draw the string. So, well, actually, I don't know if we can draw return characters. I don't know if we can. Can't. Maybe we should do that. Maybe we should add that in. No. Go back to the original way of doing it. Okay. So we'll just flip that by 0.5. Then we kind of want to draw somewhere the names. I'll just draw it next to it for now. So vec2 p equals bounds dot top right. So we need the font and stuff. Editor.get font. Get board font. Auto font size. So that's a reference as well. Editor.get font size. Get renderer. How do I get the font size? It's canvas. Is it canvas? Get font size, yeah. And then the line height is editor. Get line height. Get board font line height. So we just want to go draw string, canvas, string. Isn't a drawstring in world. So this has to be canvas world to pixels. Bounds.top right. P. No, it's the font first. Font. Font size. Text, which is name. Float color. So we'll cache out editor colors there. We'll say colors.white. Back color colors.black. Position is P, Z. Let's say it's int max for now. Then we're going to do P.y plus equals line height. Okay. For the font size. Let's see what happens. Get rid of these compiler errors. So we could also do this, because if it doesn't have a name, we still want to know. Unnamed or unknown name. Right. See if we get Spidey pop up by that green box. Say that Spidey is the one that is triggering this behavior tree. Oh, let me have. Oh yeah, that's fine. If this works, I'm going to have a coffee break, 2 minutes. And then we might go on to actually filling out the action, the behavior action, and get him to try and get cover. What's the problem here? Spelt that wrong. So that would be in behavior types. We've got this action, combat, find cover. So this is what's causing the infinite loop in the behavior tree. And this means the Spidey does nothing because it just returns running all the time. So this needs to basically, so we can enter this on the condition I mean, we could hard code a condition to enter the actual action, or we could use it with the editor. So we could say, like, if the Spidey has got less than 10 HP, go to cover. And then the actual on tick would be, it needs to like scan. Needs to scan the entire, needs to like do a raycast or something to find out a good position to do cover, to like go to for cover. So it needs to do a raycast from the player to find a good place for cover. It's away at the opposite side of the world to the player. Opposite side of the room or something. Right. That'll be interesting. That'll be an interesting thing. Try and implement. Right. Didn't actually link it properly there. Okay. All we want right now, though, is to see the name of Spidey and is the guy that is triggered that action to run. Oops. There he is, Spidey. Okay, so it's actually in the wrong place. It's because we flipped the space over, didn't we? Here. So it's actually bottom right. Because, yeah. It flipped over to screen space, so the top right is here, because in screen space, 0 is here. And in world space, 0 is, well, 0 is like in the middle. There we go. So we'll just get a list of all of the entities triggering this action. So if there was more than one entity triggering this action to run, it would appear here. So we know that the Spidey now. The main thing is we know that the Spidey this Spidey in here is causing this action to fire. So hopefully That will save us a bit of time when we need to debug these node trees in the future. Right, I'm going to have a 2-minute break to make a cup of coffee, and I'll be back shortly. Okay. So now we can make this action do something. So my plan is, if he wants to go and hide, we know as humans the best place for him to go is here. How do we tell the game that though? We need to basically fire rays. We need to march rays. What do we need to do? We need to get... We don't need to march rays. We need to get the vector from the center to there. And then we need to push the vector out until it's not in a collidable zone anymore. And that will get there. So there's a little bit of ray marching. So first thing first, let's just draw a line from there to there. So it might be worth actually putting another bit of collision in. Where's the hero spawn? Hero spawns here. So we'll put another bit of collision. So if we make the hero spawn about where we are now in the game, we'll just put another little bit of collision here. What layer is this on? This is on the floor as well. Yeah, so we'll pick that one. And then so you can hide behind those barrels or those barrels. Might not enough. It might not have enough space to get through there actually. Let's move that up there. Make sure it has enough space to walk through there. Is that? You should have enough space there. Okay. So we'll just do it. We'll do it like that. All right. Rerun the game. So you've got two choices. Two choices to find cover now. You can't fit through. Move it up here then. I think you can fit through there. Let's just... Yeah, I'm pretty sure I can fit through there. So if I'm stood here, that is the best place for him to find cover. If I come up to him, he needs to move either behind there or behind there. It's probably... We should probably make him pick the closest one. Right. So... we have something called collidable cells. I think I should maybe draw those out here. So auto level equals get game state dot get current level. Auto room equals get game state get current room. Is it the current room? It's the room. I suppose it doesn't need to find cover if... Yeah, so get current location. Get location. So that's where we are in the world. So that's a reference. I don't think this includes game state, does it? It does. Auto game state equals get game state. Oops. I might do get NPC position. No, get NPC location for state dot playable character. So this is a lock. PC lock, right? The playable character's location. And what we might do actually is cache out the playable character. So we've got the playable character's location. So we need to go, let's do level, get collision cells for the PC lock room. Standard 2 underlying PC. Collision type. Animated rig, I think. And they're collision cells. So we're going to say if PC lock, if not PC lock, no, have to return fail, right? E-behavior state fail because there's no location. So we get the collision cells. Is that what we want to do? Do we want to get the cells? Or do we just want to get the actual collision? The thing about collision cells is it doesn't really, we don't really say what collider it comes from. So we do have points there. So I wonder if each cell needs to know its collider ID. The cells is the things we need. Okay, let's just get colliders for a specific room. We don't need to do that. So let's just work on colliders for a second, not cells. Cells is going to be the thing that we need to determine where to make the Spidey to set the new Spidey in position. We'll just work with colliders at the moment. Get colliders. If collider room ID is not equal to PC lock room. The room ID is just the hash of the room. continue. We've got all of the colliders. Oops, continue. We've got all the colliders. So the collider is in this room. I think all we're going to do is we're going to do auto. Let's get the canvas. Just do canvas dot draw line in world from the PC lock position to collider. Now then, we don't save the bounds of the collider. We should probably do that. Do we have geometry? Get center. We do, so we'll just use that. Geometry. Get center of a polygon. Ooh, is that right? Yeah, that's the right one to do. A bunch of points. So that will be collider points. Let's draw it white. Okay. So we need to include game canvas. So this should just draw a line to the colliders. When he gets down there, starts running this. All right. So we should draw the cells as well. We should draw the cells. Where's the cell? What is a cell? So vec2i. So cell bounds equals bm cast rect. Rect bm cast vec to a vec2 cell vec2 one more. So basically we just have to keep adding to that line until we're not in a cell anymore. Okay, now we're not drawing the cells. The ID is actually standard rig. What is it? E animated rig type. Because it's the cells for this current rig. So it really needs to be on the animation controller, doesn't it? So we need to include animated rig types. As well. Okay, so we're drawing the cells. Oh, actually, no, it has to be. Okay, so we need to actually stop drawing the cells wherever we're drawing them. Before as well. Here. So we might actually as well standard span 2i cells. The span, yeah. And then we're going to say no. Go auto c equals state.get animation controller for the entity ID brain.entity ID. If not AC, return eBehavior state fail it. And then this is AC get animation controller type. Now I think this should be called get animated rig type. Now we changed the name. Right. It needs to be on the current whose brain this is occupying, because who owns this brain instance, because they're the one that are going to have to move. So it's going to be, rather than the playable characters, rather than the heroes cells, it needs to be the brain entities cells. Ugh, mouthful. Get animated rig type. Path. Oh. Oh. We don't actually have it. Get type. So this should actually be called get animated rig type. Animated rig type. All right. So we're just drawing out a bunch of debug stuff now. So now we need to march the rail on until we're not in a cell. Which is fairly easy to do. We're not going to test if we intersect cells though, we're going to use the hashes because that's much faster. we'll come down, settle down, and there we go. So we need to increment these by 1. Like that. To basically until we are outside. So all we're going to do is we want to get the hashes as well. Get collision hashes. So we're going to go, so we've got this line, right? Do I have a thing called the line segment? Well, got P0, which equals to the PC lock position. And then we got P1, which is geometry gets center collider points. So maybe we just try a maximum number of iterations as well to make sure that we don't go off forever. Try 100 iterations, and then so for I to max iterations, right? So we need a direction. So that goes from there to there. And that needs to be normalized. So we're going to go we say P1 equals, well, auto P3, P2 equals P1 plus D times I. Like that. And then I'm going to say auto hash P hash plus hash 32 of vec2i BM cast vec2 I P2 dot floor. If standard ranges binary search, the range is the cell hashes P hash if not so we're going to do vec2 p2 equals p1. Whoops, what did I do there? Just a random hotkey. We break. And then all we're gonna do is just do canvas, draw line in world, draw quad in world. Rect p2 dot floor vec2 1 1. Well, I'll say draw quad outline in world. Stroke pixels to world. Let's draw it 1. And we'll draw it green. Right then. So this should draw one green box for each collider of a suggested place to go for cover. So there or there. And if this changes, this moves. Whoops. Yeah, so these green boxes are like, you can go for cover there, you could go for cover there. So I think we need to pick the closest one to the Spidean. So we're going to do T-array of vec2 candidate cover points. For auto P and candidate cover points, we draw it. So we want to pick the closest one. So we don't really need to store these actually. Just pick the closest. Take that back. So we're going to say vec2 current cover point. So let's just do standard optional as well. Vec2. So it might not be one. Current cover point. What we need to do is we need to go D2, so it's the distance to the Spidean, so we need to get that location. State.get movement control of the brain.entity_id. If not, MC return eBehavior state fail. So what we want then see if PC lock room is not equal to MC get location dot room return fail. They have to be in the same room for this to work. So D2 is P2 distance squared MC get position. If D2 is less than do that. That will work. If not that or that. D2 equals P2. So I'll pick the closest cover point, and then we just say if current cover point, we will draw it. Draw it like yellow. So it's the closest one to the Spidey, so it has to move least amount of distance. The quickest point to cover for him. So let's pick this yellow one here. So if there's a current cover point, so if there's not a current cover point, we return fail. So I think this needs to be part of the global state. That's not serialized. Serialized. So we also do want it here. I'm going to Call this the next cover point. So we're going to say, if there's not a next cover point, we return fail. If the current cover point is not equal to the next cover point, we set it. And then we need to actually tell Spidey to move. So we have to do MC move to. Now does this? Yeah, move to current cover point. The max move speed is SC. Get walk speed. What does this return? It's a standard optional vec2, I think. Const standard optional vec2. That's what it passes in. So we need to be running until we meet that point. So this is behavior state behavior state. So what we might, it would be nice to actually have, to just be able to call fail with the instance, wouldn't it? Which sets the behavior state. It'd be nice to just have like a fail, succeed, running. I'll just put this here. Maybe need to do that. We could just do behavior state equals fail return state, like that. Have success and running. So we could do that. Make them static. And then we can just say here, we could say fail behavior state. So this returns the state. So this is fail behavior state. This is return running behavior state. And this is behavior state equals success. I think that does it. And that's behavior state. Oops. So it'll come along. If there's not a next cover point, they'll fail. If it's a different cover point to the one we have, it will set the new one and it'll begin moving to it. And it'll return its running. And then if it's the same, it'll just return the behavior state until Spidey's got to the location, and then it will set it to be success. Depends if you want to define success as actually getting to the location. Ooh. Let's see what happens. See if he moves. Oh, he's scared. He's gonna move back there. And then he's gonna go on to his normal patrol again. So if we move, okay, so he did it once. I don't know if he's not. Looks like he's not going to do it again. Oh, I think because we need to reset the current cover point when we enter. Now our cover should probably wait. Like, what is the... It's going to have to be like waiting for something. Yeah, so the patrol basically ends there. Not the patrol, the behaviour ends and just resumes his patrol. Let's see if when he comes back, he chooses again. He doesn't. Okay, so what's happening there? Mosh, how's it going? Hope you're alright. Got any questions, just ask. So he's not coming back to it. So let's just see what happens. Why is he? Oops. Why is he not coming back? So there's no instance there. So the instance was marked as successful. Right. Yeah, I hope you're doing alright, Mosh. I need to change my chat window so it shows when people spoke. Hey, alright. How's it going? Yeah. Yeah, so it runs once until it's successful and then it won't run again. Is that the way we want it to behave? Yeah, see you later. Yeah, what do we want to do to reset these trees? I think if you... Okay, let's just check. So he's going to go up and he's going to find his cover location. Okay, and then we call enable resume conditions, of which there aren't any. Or maybe it's here, and then we check resume conditions when we get back to that node. I think we have to just mark the brain instance. Okay. So this test one's unavailable. This one is available. So it needs to call. Okay. So it needs to set the current node ID to be 0. I think, to make sure it calls begin again. Alright, so we can enable the resume conditions. And then when we get back here, sets the current node ID to 0. And then it calls begin. Okay. So we're back again. All right. Let's just see if let's just watch it for a bit. It's going to go and hide. And if I go and stand here this time, it's going to choose to go and hide there. All right, cool. So that's him fleeing. So this is currently on an activity node on the patrol. I think it needs to be a default condition though. Default behavior. Behavior combat. So let's try that. So this should always tick. There's no conditions where this doesn't tick now. All right, so it's not doing anything. So it's not ticking any node there. Why? Game state. So it's here, isn't it? Spidean is running default behavior. Fail. So it's not running its default behavior. Reset default behavior. Okay, so there's no available patrols. No available behaviors, was it? For this patrol. So there's no available patrol. So it didn't. So the level patrols. NPC ID 23. That's completely wrong. So what's happened there? Should be NPC ID 5. Rebuild those patrols. Level. Oh no. Maybe we need to rebuild. Actually rebuild the levels, not the patrols. Where are we? Patrol groups. 3 patrol NPC IDs. So let's rebuild these levels. NPC ID 23. Level. Patrol groups. NPC ID 23. So have I changed something there? Maybe I have. Oh. Did I do that? I might have done that. Maybe. Try that again then. Alright, so all I want now is to put a default behavior on the patrol, meaning the behavior is going to try and run first. There we go. So that's a bit weird, but that's fine. Now he's always going to try and find cover. So these warps here. And figure out what's going on there. So when we're doing that, that's because it's going to the same location all the time. Or is that because we're resetting the location? Fix that flicker. So it's succeeding on the patrol. And then... where are we? Behavior controller. Behavior... what is it? Behavior types. So it's calling this all time. So it's this move to really, I think. So we're very close actually to where we are, where the actual thing is. If we're already there, if the movement controller's position, where is that? The position is 1.36 to 3.02. So if the distance is less than 1, I'm going to say if current cover point, well, current cover point distance squared to the MC get position is less than 1, less than or equal to 1, return success behavior state. So if you're already there, you don't need to move again. Okay, so he's still trying to move. He wants to resume his patrol after, I think. Where he sits down there, that's because he's not been able to solve for the path. He's definitely trying to run away from me. A bit janky. So this is succeeding, and then it's going on its patrol for a frame. And that's why that's doing that. So let's just have a quick look at the brain. So he's repeatedly calling that tree. So how do we really want to handle that? And the bots are big today. The ban bots. How do we really want to handle that? He needs a reason to be in retreat. So I think he needs to go and he needs to wait there. And then we need some other condition, which is like, if we get close to him, he needs to retreat again. So we want like a wait action. So like this breaks off and this is a sequence. And the wait is running So it needs to be like a wait till NPC in radius or something. So we can either do a wait, and then we could put a condition on that here, which is like distance to NPC. Or we could just have a wait until NPC in radius. So we could have a wait until, and then we could have a condition. Distance to NPCs is less than. We could just write it in code. I think we'll write it in code for now. Maybe we'll do wait until. So we like behavior action. So this needs to be called NPC combat. Behavior action combat NPC find cover, I think. And then in the brain file, where we have the wait, where are we? It's the Spidean brain. Combat brain. This is NPC combat find cover. Whoops. NPC combat find cover. No, it's combat NPC find cover, isn't it? Let's just check that loads. Well, no, we'll write this one now, because we're nearly out of time. So this is combat NPC wait. Well, it's not even combat, is it really? This is just NPC wait. Wait on condition. Not NPC. Conditional wait. Wait. So we want the NPC. We want the current position. Don't know if we need that. Like that. And then these two. And that one. So that is just the same as this. So this is current position. Reset. So we have to do current position dot reset, and then we're going to go auto MC equals get game state dot get movement controller for the brain dot entity ID. If not MC, return fail. Else return running. Okay, so we're just going to go, that's basically to set the current position equals MC get position. Now actually it probably needs to be a game location. Difference between a game position and a game location is the locations is like which room is it in as well. The position is like the point in space. This is the point in space and its location in the world. So the current location is that. And we're going to say if not current location, return behavior state fail. Get the move controller. And then we want to go if current location is not equal so I wonder actually if we need what cell it's in. We'll do it by cell. We call this. We're going to call it current cell. Current cell equals current location equals EM cast vec2i MC get position floor. That's what cell it's in. Room is not equal to MC get location of room. So I might have to call this next location. Not in the same room. We fail. They are in the same room. We need to get the cell. I'm just going to say if current cell is not equal to next cell, return fail, return running. But basically, it's you have to wait there. Right. So we might just do W string front room. Specifically test the room. All right, cool. So this is the wait now, and this is going to wait forever, or until something else in the game physically moves the spider in. What's the problem? What is the problem? Oh, this is not trivially binarily serializable anymore. Oh, it is. It still is. It's not serialized. Those things are not. Strings not serialized. What's the problem? Got a link error on this tuple now. Ensure behavior action storage. It's not actually a link error. It just needs to actually compile it. It's the game. It's not a link error. There we go. Okay, so now I'm just going to attach that behavior action onto the brain. Conditional wait Biden. Whoops. Okay. Let's try and hop. So now it's calling conditional wait. And that'll just wait forever. So what does a condition want to be that it waits on? We don't. Distance between NPCs. Basically, if we come too close to it, it needs to do it again. So he's going to go to cover and he's just going to wait there. So we need to write a condition now. So we could be the condition that we go into a trigger. Just to test this trigger here. So if we just copy this trigger ID, the condition is going to be a trigger condition when the hero enters this trigger. Oh, it's like a fail condition though, isn't it? So we could actually put in failure conditions in here in the action, because the condition that we want this node to enter is that we're outside this trigger. The condition we want for this node to work is if we're outside this trigger. So it's a bit confusing, like a double negative. Maybe we only evaluate the conditions once though. Yeah. So actually, we need to put separate conditions here. So conditional wait, and we want like failure. Do we want to have failure conditions or wait conditions? Or we test these conditions every frame. Maybe we should test them every frame. So when we tick this, we should need to maybe test the conditions every frame of the node. The current node has conditions on it. So right now we only test the conditions when we set the node. I don't know. All right. I think I'm gonna have to call it a day because I'm getting a bit knackered. But we did do quite a lot today. Anyway, he goes and he waits there. He finds cover and he waits there. We need to be able to break this wait condition now. But we will resume that tomorrow. Oh, actually, I'm not in tomorrow. We'll resume it on Friday. I'll see you guys. Well, I tend to stream every weekday, most weekdays. Can't do it tomorrow, unfortunately. Yeah, thanks for watching, and I'll see you guys later.